Very good evening to everyone. Welcome to Pantechelearning. Hope you can listen my voice properly. Having any problem with the voice, please check now itself. Good evening to everyone. Good evening to all. Hope we completed the first class successfully. Today we are just starting the second day on FDP, A and deep learning with the autonomous vehicle based. Yeah, fine. I think hope my voice is audible to you all people. Having any disturbance, just please keep message. Yeah, the voice is okay. Fine. Thank you very much. Thank you so much. So without delay, we can start our session. So today we are going through with the day 2 session with deep learning based image classification and as well as YOLO object detection, and along with that the YOLO object detection with normal SSD based object detection also we have to do, and we can see that particular architectures and all. So now we are starting the first thing. So we discussed already, without delay anything we can start the consent. So here we have to discuss the first thing is, because today the entire process will be in a deep learning model. We are having so many type of models. In that particular models we have to take some two models, that is about YOLO based with the RCNN as well as with the CNN model. Now we will see the first basic architecture, everything and all here. Okay, so we haven't discussed exactly how the layers are working yesterday, right? So we just skipped it. So today we can see how the layers are working. So I said to you, if the neural network construction you have to do means, so with the input layer, hidden layer, output layer, along with that you have to follow the bias functions along with the activation functions, right? So now we will see how the all functions are available and what is the definition of each and everything we can see. Here you can see the input features you are giving to the weight features, and here you can see the definition of the weight and bias. So what is the meaning of the weight and what is the meaning of the bias? So weight is nothing but, so it's representing the strength connection between the neurons, means what are you having the weight feature values you have to identify by using of the weight features with the weights keyword. So coming to the next one will be bias. So bias is nothing but the simple thing, you have designed one particular thing means, so without making checking it's not possible to upload directly into the particular software setup to the hardware setup, right? So that purpose we have to check at least once, right? So if you want to check like that and you want to design the best designing part, then we have to go through with this bias function. So in this bias function I said we are having three type of options yesterday. One is about the activation function, and second one will be the loss function, third one will be the parameters. Today we will see how the process is going on here. So the first one will be activation function. So activation function we can give at the hidden layer and output layer based on the requirements. The first one will be sigmoid, second one TANA, so TNAH, the next one ReLU, leaky, ReLU, softmax and linear. So actually our activation functions will be two types, linear and non-linear. So linear is nothing but is like a normal process, and non-linear is nothing but it's like we have to take the random output to get the better accurate results. So that's why we have to use the non-linear activation functions. The first one we will discuss about the sigmoid activation function. So whenever you take in this particular sigmoid activation function, it will work for the binary classification. So this sigmoid will work for the binary classification, and how it's working you can see that. Coming to the next one as TNAH. So this will work for the generation of the data. So that purpose we have to use. And ReLU, rectified linear unit. It's very related to the linear function, but we are having the rectifying process here up to some particular peak value. That you can say it as a rectified linear unit. This may can use for hidden layer and as well as the output layer too, and sometimes we can use input layer also after input layer. Next one is coming to the fourth one is leaky relu. Leaky relu is nothing but some leakage process will be there here. You can observe this particular relu and leaky relu will be the same. So we are having the modification of that leaky area. So that's why we are saying it as a leaky relu. And coming to the next one, softmax. So this is very important because in a present days we are not doing a single classifications or two type of classifications. We are doing so many type of classifications like normal, abnormal, not. If you are doing some particular classifications, it should be a multiple classifications. If you want to do the multiple classifications, the sigmoid is not enough, leaky relu is not enough, TNAH is not enough. So we have to take the probabilistic manner to get the better accurate results. So that purpose we are using softmax activation function. With the probability we will get the multiple classifications outputs. So I am saying the main keywords. Please try to understand that particular main keywords, because if you want to create, you are having the layers from the TensorFlow library or PyTorch library. If you want to build those particular layers based on the construction steps of the neural network, then we have to select some activation functions, related activation functions. We have to select some loss functions, proper loss functions we have to select. Based on a selection of the model, we have to select these bias functions. So coming to the next one will be linear activation function. It should be workable for whether it having the problem or not, like that. We can see this linear activation function for input and hidden layer purpose, and as well as we can see for the regression models. So these are the activation functions what we are having. So now we are seeing next one, how to select the activation function. I said right, we are having this activation functions, but these activation functions we have to select based on a requirement. So now you can see in this particular first point, so the binary classification purpose, what we are selecting for the binary purpose. So here for the hidden layer purpose, in a binary classification we are selecting relu or leaky relu, but for the output layer what we are selecting, sigmoid function, because we need to get the binary output. That's why we have to take through with the sigmoid function. Coming to the next one is multi classification process purpose. We have to take for the hidden layer as like a same relu and leaky relu, and later you have to take the hidden layer purpose softmax activation function, because it's like a probabilistic manner we are having. So that's why we have to take this particular activation function for the multi-class purpose. And coming to the next one, in case you are having the regression parts, then we have to take only the linear activation function, like for example linear regression or logistic regression. Any linear type manner you are having means you have to take these particular things. Coming to the next step, you are having input, hidden and output layers. In that we used it till now only activation function. How to take we have seen, right? Now you can see how to take the loss function. If you want to create the model, how to take the loss function you can see. So here you are having the three options. So what is the three options? MSE, MAE and as well as the binary cross entropy and categorical cross entropy. So by names itself you can say whether it will be work for this particular area or not. So MSE, MAE, where we can use error rating purpose we can use. So mostly in supervised learning or unsupervised anywhere, so where we can use error rating type of models for the regression part. So that MSE, MAE we can use wherever you are getting the loss data. We are not calculating, we don't want to calculate directly accuracy process. We can take the error rating sometimes, right? So for example, the person getting the 90% marks means, so 10% will be the loss. If you are find outing 10% will be the loss also, you can say he is getting a 90% of marks. Anything is same, right? So here based on a construction of the model, we have to select these particular things. So that's why I'm selecting here MSE, MAE for the regression model part. because the error rating will be there. Even though we can use in this GAN model, generative adversarial neural network, also we can use MSc MAE, because there we are taking the error rating process. So coming to the second one, a loss function, second one will be, so binary cross entropy. So I said why we have to take the activation function. So what is the meaning of the exactly activation function? So otherwise you'll get the same problem further. So try to understand that particular activation function is what. If you want to get the output in a proper way for the construction of the neural network, then we have to select this particular activation function. So why you are taking this particular loss function? The loss function, you need to say whether the construction model is giving the accuracy or loss based on the training process, based on the prediction of inference mode, means the output prediction purpose, we can use it, right? So here I am taking the second one will be binary cross entropy. The binary cross entropy is nothing but it related to the binary level based classification purpose, we can use it. So there you can get loss or accuracy based on your construction model. And coming to the third option will be here, categorical cross entropy is nothing but you have to do for the multiple classifications. So you can see, you can compare the activation functions and loss functions easily, we can say. For regression part, I can take the activation function as a linear with the loss function of MSc and MAE, and coming to the multiple classification purpose, I can take the softmax along with the categorical cross entropy. And if I want to take the binary classification, then I have to take the sigmoid and as well as the binary cross entropy. So like that we have to compare all those functions and we have to select some particular functions. I am not saying you have to take in a same manner, based on a construction you have to take. So this is the first one, MSc and MAE. So mean square error and mean absolute error we have to calculate based on the summation values of your requirements what you are having exactly. So this will be applied for the regression problems, I said, right? So yeah, so we have to take these particular things because it is possible for the regression model part. And coming to the next one will be binary cross entropy. What is the meaning of the binary cross entropy? So binary cross entropy will work for binary classification problems. Here itself you can say how and where it will work exactly, right? Because we have given here very clearly with the particular single line of the definition, then you can understand easily why we are using this particular loss function for this particular requirement, right? So coming to the next one, next we can see, after completion of this one you can see categorical cross entropy. So then what is the meaning of the categorical cross entropy? So what is the use of this particular categorical cross entropy? So these categorical cross entropy will work for the multiple classifications, that is only have already discussed with you, right? So now we discussed activation functions and as well as the loss functions. Now we have to take the optimizers. So why we have to take the optimizer means to boost up the algorithm, and in these particular optimizers only, if you are training the database, that should be boosted up, and as well as we are having any loss of information, it can balance it properly. So that's why we have to take here the optimizers. So in a many manners we can say. So here you can see the gradient descent will work for the machine learning models and as well as regression model part type. And coming to the Adam optimizer, we have to take for any type of deep learning classifications. Why we are having the gradient descent means, why we are coming to the Adam optimizer? What is the use exactly means? The simple thing here, if you are taking any type of the particular database, so this will be will work for only for the machine learning based content. So coming to the Adam optimizer will work for the any of the neural networks, then there we have to take. But Adam optimizer only not there, we are having so many of the RMS speed, something like that, we are Adam boost something, we are having so many of things. But apart from that, we are using this Adam optimizer more. So this will be uh, reduced uh, for overfitting and underfitting process. That is also one of the advantage for it. So here you can see how the gradient descent is working and Adam optimizer is working. So for this particular area, we are having two options. If you want to construct the neural networks, so I said, like, if you want to construct the neural networks with the Python language, so we have to take some particular libraries, right? So for example, if you want to work for the so if you want to work for the neural network construction, we have to say take some particular libraries. That will be TensorFlow and Keras. Otherwise, you can take the PyTorch library. What will be the difference between this TensorFlow, Keras and as well as PyTorch means? So TensorFlow is a machine learning library to give the backend purpose for the deep learning model. So what is the meaning of the Keras means? Keras will work to load the huge amount of the data here. If you are combining this TensorFlow and Keras, then we can start the process to work for the neural network model constructions. For example, if you want to take the graphical representations in a Python language, which library you can take? Seaborn, Matplotlib we can take, right? So like that, if you want to construct the neural network model, then you can take TensorFlow and Keras. But this will work in CPU more. If you want to work for the huge amount of the data, like terabyte, petabyte, you have to take more. Because in real-time applications, whatever you're taking like MBs or GB data is not enough in real-time applications. So in real-time applications, it's possible sometimes you can take the GB data also, no problem. But that for small applications in real time. If you want to take the huge amount of the applications, then there we have to take the much more better information. That's why this TensorFlow Keras will work for the CPU efficiently for the huge amount of the data, but not that much. But coming to the PyTorch library, we are having the PyTorch library. Wait a minute, I will show you that. So we are having the PyTorch library. This PyTorch library will work for the CPU and GPU process for the much more huge amount of the data. You can give gigabytes, terabytes, petabytes, anything you can give. So compare with the TensorFlow Keras, then we are having the upgrade version of the PyTorch. The simple thing. It's like a upgradation you can say. Otherwise, it's like a family type you can say. So in TensorFlow Keras also you can construct the neural networks. Even in PyTorch also you can construct the neural network. But based on the requirements, we have to select our model. If you are having the less amount of the requirement, then why you need to take the PyTorch? If you can go through with the TensorFlow and Keras. If you want to take more, then you can take the PyTorch library. So like that, we have to select our models what we are having exactly. That is a requirement. Okay, so now I will tell you that particular requirements, how it's working exactly. So you can see example purpose we are taking today, artificial neural network CNN and RNN. Artificial neural network is the basic construction. In this particular construction coding part you can see. So in this particular construction we are taking like ReLU and activation function will be the softmax. So coming to the next model will be convolution neural network. We can discuss later again and again. Because the construction everything we are having in our future, we can discuss further. Recurrent neural network will be there. So this construction also you can check. Here we are taking RNN purpose sigmoid and as well as for the output layer. Okay, and before that we are taking some another layer, I mean another activation functions and all, right? So we have to select all those requirements when you are constructing the model. Now we will discuss about the convolution neural network. Why? Because today for the image classification and for the YOLO of the detection, mostly the construction should be as like a convolution neural network only. So that's why how to tell about the convolution neural network. So here you can see convolution neural network. What is the meaning of the convolution neural network means? So you're having the deep neural network. In that particular area you're having so many type of different type of neural networks. So NN, RNN, RCNN, GRNN, GAN. Okay, so like that you can take in CNN also. We are having CNN with mobile net, dense net, VGG, and YOLO based, and as well as like we can take like with the segmentation part, and we are having so many type of options here. Okay, so it's not enough with a single construction. Based on the layer changing modifications we are having so many, but each and every model will be applicable for some particular application. For example, you can take some particular mobile. If you are taking the Vivo mobile, then we can say some particular, this is very popular at some particular thing. If you are taking Oppo, you can say it's very popular about the camera. And if you are taking a Samsung, it's very popular about the strong. Like that, every mobile, how you are saying the specification, best specification, like best specialization, how you are saying in a construction of the model also they have selected like that only. ANN will work for the normal classification, RNN will be there, right? That will be work for the audio classification based. Like that, the convolution neural network will be work for the image classification. So what is the meaning of this particular convolution neural network? How it's working exactly for the image classification means you can see here. So this is best at image classification process. Now you can see this particular picture, then you can understand how it's working exactly. So see, this is about the convolution neural network, right? Here you can see, if you are starting the convolution neural network, it has a 4 layers. What is the 4 layers? First you have to take the convolution layer, second one pooling layer, third one will be flattened and fully connected. Finally you have to give here what is that, bias functions with the activation function, loss function, and as well as optimizer. Finally you will get the output. So that purpose, so the first one what we are doing means, in this particular area you are taking one particular picture with the name of zebra. Okay, you're having another picture and that the name will be cat. Okay, example purpose. So from that particular 2 pictures, randomly it selected one picture and that picture is converting into the parts. These picture I am just dividing into the 4 parts. So what is the meaning of the definition of the image? Combination of the pixels. Combination of entire pixels we can call it as an image. Combination of the frames means the picture, so you can call it as a video. Combination of some pixels we can say it as like a kernel. So here what we are doing means, the original picture we are not dividing into the pixels directly. So the original picture we are dividing into the kernels, small parts. So these picture we are converting into example purpose 4 parts. The 4 parts you can say it as a convolution with the ReLU activation function. So coming to the next one, the 4 parts will be there, right? These 4 parts, each and every part we are dividing into up to least pixel value. So for example, your picture you are taking means, so in this picture you are having for example 1620 pixels will be there, the boxes, small boxes. Okay, so 1620 I am not dividing directly. First that 1620 pixels I am dividing into the 4 parts. The later I am dividing into the small parts. Why we can directly can divide that pixels, right? Why we are doing first kernels then later pixels means we can't damage the picture at the end of the each slide. That's purpose we are just taking this particular convolution and we are just splitting into the what is that particular pixel values. So this is the option when you are going through the convolution to the pooling layer. So now we completed 2 layers, convolution, pooling. Convolution is nothing but splitting into the main kernels, and pooling is nothing but each and every kernel can divide into least pixel values. So now this combining of convolution plus pooling you can call it as feature mapping, means feature extraction you can call. Okay, then later now you got the features, okay, based on the dividing and each and every pixel, then you got the features. Then what you want to do, you have to reconstruct the picture. For that purpose you are using the flattened and as well as later you are going through with the fully connected layer, that you can say it as a classification. Along with that, you have to take the activation functions, loss functions, everything. That's why we are giving here software's activation function for multiple classifications. So like that, it can train and it can do the classification as well. See, our brain, we don't know about one particular subject. Social, we don't know about some particular social subject. But if you learn the 4 chapters, then you stored into your brain. So previously your brain is empty, but when you studied, then your brain will be filled with the content. Now any person is asking the question, then it's easy for you to give the answer, right? So means your brain sometimes is working for the training, and sometimes to give the answer for pre-trained model purpose also your brain only working for 2 times. Training purpose and as well as for the prediction purpose, both times you are working your brain only, right? In the same manner, this model classification will work for the same. You can take this classification model for training and as well as for the classification of the prediction. Both we can take. So this is only we have given the theory. Then you can see here how the construction layers will be there. If you are taking tensor locus, then you have to take the sequential manner. In that particular area, you have to take convolution 2D, max pooling, flattened and dense layout. So what is the meaning of this dense particular thing means? So you have to select this particular empty model to create the empty model for training of database later. So simply first you have to create the empty model. So here you are just creating the empty model, that is okay, fine. So if you are creating that particular empty model, later you have to train the database, right? So that purpose you have to select some particular space activities. That purpose I am selecting here dense. You may select a mobile net, you can select a VGG 16, 19 and as well as like a ResNet you can select, and like that you can select any type of the model what you are having in the CNN. That is based on your pre-trained model content you have to select here. So that is the use of the thing. So later you can see the construction you can see here. So first you are taking the sequential process, then later you are taking convolution of 32 3x3 matrix, like this you are dividing, and activation function you are giving as ReLU, input shape you are giving. Next one what you are doing, max pooling you are doing. The first one convolution, next one max pooling, again convolution, max pooling, then you are giving the flatten. Now you are giving the activation function at output layer, and you are just going through with the activation function as a softmax, because for the output should be a multiple classification. And at the end of the time you can see we are just comparing this empty model. Why I am saying this is empty mean just we are constructing the empty CNN model. When you are applying your database to this, when you are fitting the database to this particular empty model, then only it will start the training. So here you are applying the Adam optimizer, and you are taking a categorical cross entropy. Why you are not taking binary cross entropy or MSCMAE? Because you are doing here multiple classification. Then finally you can see here you are applying your data. So to this empty model you are fitting your training train part of the data with the number of epochs, with the batch size, and validation test will be something. So because of these, the empty model will be fit with the new database. Then it will start the training process for entire database of the train part data. Like that we have to complete our CNN model. So this is only you can see that. So now we are just going through it. You can see in depth of the convolution neural network you can see. So black and white RGB values, like how it's taking exactly in a background you can see. So how the convolution operation is going you can see exactly. So like that we have to split the picture into the parts, and here we have to apply the filtering technique. Without filtering is not possible to get the better accurate results. So like this it's possible. I said right, we have to divide into the kernels with the filters. So this is only like this we have to follow. This padding process will be appear when you are starting with the pooling part layer. So like this we have to follow all layers. So hope you understand this one. So in a same manner, for the PyTorch also we are to do the same thing, but the construction will be different. That's it. Now we will start our applications with the image classification using CNN. So today we are discussing about image classification using CNN, and as well as YOLO object detection, and as well as object detection with the SSD. Now we will see these particular applications. So hope you understand this theoretical part, and if you understand this one, then it's easy for you to crack like some particular content what I'm trying to say. Because I just want to tell about the YOLO. Yeah, okay, we can complete the YOLO part here itself, then that is easy for you to understand the application. So I didn't tell about the YOLO, right? So we have taken the YOLO, so but we didn't explain it, right? So image classification purpose you can understand, but coming to the YOLO you can see. So what is the meaning of the YOLO? So YOLO is nothing but you only look once. So whenever you are starting this particular process, then you can identify the features. When it's looking once, then it can easily grab the features of the particular objects. So that's why you are taking the YOLO. In this particular YOLO, you can give so many type of options. RCNN you can give, what is that, CNN you can give. So based on the constructions, regions, everything you have to take. You can see here. So you can apply this YOLO, and we can apply with the SSD, and as well as mark RCNN or RCNN also you can do. Okay, so we have to take this particular YOLO object detection. So this YOLO architecture also will be the same as like a deep learning model of the CNN only. If you understand the CNN, then YOLO architecture also will be the same. The same layers will be available. The construction should be little bit different. That's it. You can see how the YOLO construction layer will be there here. You can understand it. So I will show you the particular layers, how it's going exactly. Now you can see the layers of the convolution neural net, YOLO. So how it's taking the same layer part only, but we are just taking based on the construction model, based on the YOLO part. That's it. That is only we are saying it as a YOLO Pro model. But compare with the normal classification, if you are taking the YOLO, it has the combination of with the blob and along with the arsenal architecture. That's why compare with the normal object detection, with the YOLO you can identify at least 90 to 95 or sometimes 100% of accurate results you will get for the object detection. So for example, now we are saying about the autonomous vehicles, right? So in that particular autonomous vehicles, mostly they are using PyTorch with the YOLO models only. Why? Because the main thing will be compare with the normal object detection. Normal object detection is nothing but mobile net SSD also we can take. Compare with the mobile net SSD. So YOLO model will be the best, because it is grabbing the picture features very clearly compared with the mobile net SSD. So that's why you can see the YOLO architecture. Here you are taking the same thing, convolution layers only, that same layers only you are taking, but you are splitting the layers into much more layers. So that is only you are saying it as a YOLO architecture. Now you can see the application one by one. So before going to the application, I just want to tell about the steps for the application. So first we will discuss about the image classification, right? So today our application is about the first application, image classification. We just want to go through with the image classification. So what is the meaning of the image classification? Any type of image classifications you can take. It's not mandatory you want to take only some particular content. If you want to work for the database of the medical, you can go. If you want to work for the animal classification, you can go. If you want to work for the identification of the human being base, you can go. Regarding for the food, you can go. And any type of content, you have to go for the classification. But mostly that should be labeled. Then only is possible to get the better accurate results. So that purpose, what you want to do, the steps, what I am saying, the steps you are following means that will be easy for you to grab this particular image classification process. Then I will show you that image classification process steps. I shown you yesterday how the steps should be for application, right? So today I am just going through with the application as image classification using CNN. So now the first step will be you have to collect the data. So I'm just giving it as a data collection. If you are following these steps, then it will be easy for you to grab the image classification for any type of images. So after data collection, we have to do the pre-process. So what is the meaning of the pre-process? Means the simple thing. So we have to enhance the databases by using of the filtering techniques, by using of the enhancement techniques, everything you can take. Simple thing. The original data we are just modifying with the removing of unwanted information. Just we are removing the unwanted information, just we are trying to give the better data, without garbage data we are trying to give. That baby images, anything we can take. So today we are taking the image classification, right? That purpose we can do the image processing. So coming to the third part will be data visualization. So the data visualization normally is not mandatory, but if you want to show the visualizations, like I have taken this particular data, I am just working on this particular data, the visual representation is very important. That purpose we have to take. And coming to the fourth step will be we have to take the splitting of data. It's not mandatory the splitting of data, because present days they are only giving directly the splitting of data into train, test. So please try to remember this one. This is not training data, this is not testing data. Just we are dividing the data into train part data and test part data. Just we have divided our original data into like this. So now what you want to do? The simple thing. Next one, create. Actually I'm not telling like you want to load the model of the deep learning. I'm saying create a empty CNN model using TensorFlow Keras and TensorFlow Keras. Otherwise what we can use, PyTorch library, anything we can take. So that is a requirement, we have to take it. So coming to the next step, after completion of this creation of the model, then what we have to do, give the main thing, apply activation, loss, and so what will be the last one? So we have to take optimizers. So we have to allocate it properly. Now you have to do the next step, fit only train part data, only train part data with CNN, empty CNN. Okay, so why I am calling it as empty CNN means I have constructed, that's it, I didn't apply anything. Then it will start the process of train the database using CNN. Then you will get the process of inference mode. So there you will get, normally before inference mode you will get accuracy or loss, that you can say it as a evaluation process. After completion of this particular evaluation process, then we have to start the test process. That is only you can call it as prediction part purpose inference mode we have to call. So here what you want to do, you have to give one input picture, then you have to do the pre-process of that single input picture. I am not giving more pictures as like a database. So single picture I am giving, I am doing the pre-process. Then later, so I am trying to do compare input with pre-trained. Why I am calling as a pre-trained means because it's already get trained. Pre-trained CNN. Then you will get the results. That may be any type of classifications you will get. But you can see, if you are seeing this particular entire requirement in real time applications, we don't want to see these entire steps. We can see only the front end part setup. You have to upload the picture in a background, it can do something, and finally it can give the output results in a output side, right? So for that purpose, how it's giving exactly means, after training of the database with the accuracy and loss, we have to save that pre-trained CNN with models. What is that models? That may be .json, or what is that, .h5, or sometimes .txt also, sometimes .pt files. Okay, so sometimes .onnx. So like that we can take some particular pre-trained options. So means the simple thing. So whatever you're trained, that I'm just converting into the exactly to the pre-trained model setup things. So that will be useful. So in real-time applications, what we can do in a website or in an app, you have to click browse option, then you have to select the input, then it will do the pre-process in a background, then it will compare with the pre-trained model of these particular things, then finally it can try to give the results. It can display into the what is it exactly on a particular website. So these are the steps. So now you can see what libraries we have to use for it. So we know very well, for the data collection purpose we can use NumPy, and as well as you can take, here we are using about the OpenCV, right? So why you want to take about the OpenCV? Because we are using image classification. In pre-process also we have to use same thing, OpenCV library. What is the meaning of the OpenCV library? Means open source computer vision. It will work for image or video based applications library. So for construction of the CNN model, we have to use TensorFlow, Keras or PyTorch. Like that, for OpenCV will use for to work for the images or video based applications. Data visualization we know very well. We can take OpenCV, or we can take Seaborn, or we can take Matplotlib. In collab means it will be the different. For splitting purpose we can take the same thing, we have to follow the same thing. And CNN model creation I said already, PyTorch, TensorFlow or Keras we have to take, and we are just repeating the same thing for all those things, that's it. So these are the libraries and these are the steps. Now we can see the application, but before going to the application, having any doubts about these particular things, then you can discuss here. Otherwise we can go directly and we can proceed with that. I'm putting CNN. Yeah, fine. Actually that is CNN only, I too knows. So based on typing sometimes it went, okay. So no need to worry about that. So just please concentrate on the content. So because we are typing continuously fast means definitely it will take some type of problems like that only, correct? No need to worry about it. So I have rectified it already, okay, no need to worry about. Anyway, thanks for saying the answer. Yeah, fine. Okay, so then we will go through with the next part. Now we will see the application. Any of applications you can take, that is not mandatory you want to take this particular application only. So I will show you one of the application with you. So I'll show you one of the application to you, then I hope you can understand how it's working exactly. So now I'm just going through with the image classification. So it's like normal image classification without doing any extension process. If you want to do the extension also we can do. So for this particular image classification purpose, I'm using the Jupyter notebook because my coding will be with the Jupyter notebook of the Encoder Navigator. So what I have done, the steps, the same steps we have to follow for this particular area of this image classification. Hope you can understand that particular steps. So yeah, okay. So image classification we will start. So for this particular image classification, we have to take three things. One is about train data, test data, along with that some coding part setup. For that you have to take some Jupyter notebook. Everything you have to start. So if you want to start this one, so before that you have to install the Anaconda Navigator in your systems. Then later you can type the Jupyter notebook. Then you can click on the particular Jupyter notebook. So after opening the Jupyter notebook, then you can go for the particular location where you are having exactly the content. So we can see our application in a Jupyter notebook. So my coding will be there in a downloads. So here I just want to go exactly. So where I'm having exactly means here only I'm having image classification. I just want to open. So this is my coding part. So here what we are doing means the simple thing. As per our requirements, we are just following here. That's it. So first you can see we have to import the libraries. Hope you understand all libraries. We have already discussed except this sklearn and as well as the TQDM. So NumPy will work for the numerical Python. When you are converting from original image to some particular weight features values, at the time it will work. Operating system for pathing, sklearn for confusion matrix, Seaborn I said already for graphical representation, and Matplotlib also will be the same. OpenCV will be converted with a shortcut name as CV2, TensorFlow and TQDM. TQDM for showing the content like this. That purpose we have to take. Okay, so that purpose we have to follow this particular area things. Now you can see as per the requirements we are just following the same content. Then you can proceed with this. Okay, now you can see first you have to take the label names what you are having exactly in your database. So I am just going through with my database. Here I can see my database with the segmentation and testing. So here I am having the 6 labels. Each and every label I am having some particular pictures. So this will be empty. Wait a minute. Okay, so you are having the each and every pictures. These pictures we are calling to here. So then what you want to do? The simple thing. So you have to give the all labels. Then the size you have to maintain. In pre-process what you want to do means all pictures you have to maintain with the particular same size. That purpose you have mentioned here. Then later what you want to do? Data collection you have to do. So we have collected the data from the segmentation train and test. So then later we are giving the loop condition. In this particular loop condition only you are loading the data. Here you are doing the pre-processing. You can see with the loop condition you are doing the pre-processing. So after pre-processing what you want to do? So you have to do the visualization means you can do the visualizations. These are the visualizations. So normal graphical representations, or you can display the pictures by using of the OpenCV along with the Matplotlib, everything. So after visualization, data collection, pre-processing, visualization, you have to take the splitting of data. So again I am showing to you. So this is about data collection. Then later you are doing the pre-processing here with the color conversion and resize and all. Then later you are doing the data visualizations here. You can see. Then we are not doing the data splitting. Why means directly we are having the segmentation test and train. We are just calling that. That's it. So then later what you want to do? You have to create the CNN model. So in this particular area, I am just taking the layers of the neural network, convolution neural network by using of the TensorFlow keras. So here I have the 6 labels of the data. That's why I have given here 6. Then later you are applying same as like activation functions, optimizers, and as well as loss functions, everything you are giving. Then you are getting the loss and accuracy for training part and as well as validation part purpose. Then later you are giving alternatingly on picture. Then it's trying to give the image classification. This is as like a C. Okay, so you can do the confusion matrix. Means we are just comparing before training and after training. So like that we have done the image classification. If you are seeing in a real-time applications, we can go through with the website also. This is about the image classification. Now we can go through with the next application will be YOLO object detection. So now I will show you the YOLO object detection. Okay, so in this particular YOLO object detection, I am having the two options. Okay, so what is that particular options means? The simple thing. So these particular YOLO object detection I am taking for the two options purpose. So I'm just going through with this particular thing. So I will show you the next step about the YOLO object detection. So previously what you have seen, that is about normal image classification with the CNN. Now you are seeing YOLO object detection process. So in this particular YOLO object detection, you have to understand means that you have to take the inbuilt step, simple steps for this you have to take. What are the simple steps means? Simple thing, YOLO. So the second application will be YOLO object detection. So this will be applicable for real-time applications. Okay, so the first step will be load pre-trained models. Why I am saying pre-trained models? Because the YOLO purpose, we don't want to take the training of content. Directly we are having the pre-trained models, CFG weights and as well as COCO names, pre-trained models. Then later you have to start the retrain of model. Simply we are just loading the models and we are just doing the retrain. Next you have to take the start streaming. So if I am typing also, I am getting sometimes attention about the meanings. So yeah, fine, thank you. So start streaming, that may be possible for stored video, or you can take a live camera or from CC camera. Okay, so why I am giving these many options means we can take from the stored video and we can start our object detection from the live session, that may be from your mobile or something like that, or from the laptop. And coming to the next one as CC cameras for the traffic based or any other type of applications, like for example we are taking like navigation purpose in autonomous vehicles. We can keep some cameras, and based on that we can start the video streaming. Then later what you want to do means that streaming process you have to done with the pre-process. Pre-process means the video you have to enhance the video. Then later what you want to do means you have to go through with the blob detection. What is the meaning of the blob detection means? The simple thing. So blob detection will work exactly to identify the particular features. So example purpose, you can see if you are opening the mobile and you are taking the front camera, exactly for the face how is giving the rectangular box, because it's identifying the all features in a particular area based on the size, shape, color along with the edges, right? That will be possible with the blob detection. So blobs, it's segregating, so like based on the size, shape, color, edges, it's identifying the areas. So after that, this blob detection, you are just adding or comparing, also you can say compare with pre-trained models. Pre-trained models. Then in our next step you can get YOLO object detection. That is only the possibility process. So this is the option. These process you have to follow for the output coding part setup here. So here I just want to go through with the stored video. So I am trying to take the stored video. Okay, so I am taking this video and I will try to do the YOLO object detection for this particular video. So I can take the live video also, no problem, that is our choice. So here I am just opening my code part setup. So here we have to do some modifications, that's it. Everything will be the same only. So I will show you the output process, then later I will explain you the coding part. So here you can see in this particular area cv2.video capture 0 will be there. That will be for the live session. If you want to give for the stored video, you have to give the stored video name along with the extension. Now you can run the program. If you're running the program, then it can start the YOLO object detection for that. So I'm just going through the running option, then you can see the output process. Okay, so it's starting the YOLO object detection, it's fine tuning exactly. So here you can see how the process is going on. So now I will show you the coding part setup, how it's working exactly. So here you are loading the libraries, then you are taking the inbuilt arguments, then you are loading your v3, CFG and Coco names. What is the meaning of this v3, YOLO v3, CFG and v3, what is it, weights and Coco names means in weights, dot weights file, you are having the weight feature of the each and every objects. Configuration is nothing but YOLO with a RCNN model or something, whatever you're using the deep learning model, that layers everything will be there in a configuration part. Dot Coco names one file will be there. There you are having exactly about what is it, particular object names, like that you have to take and you have to retrain it. Then you are starting your video streaming process. This is only for FPS rate, just forget it, and you are taking the loop condition. Then you are doing the pre-process and you are checking the blob detection, then you are applying to the pre-trained model, and here we are identifying the three things. What is that? Boxes, confidences and class IDs. Boxes is nothing but wherever you are getting the rectangular boxes, that rectangular boxes you are calling it as a boxes. Next one, confidence is nothing but you can see how much percentage is recognizing, 93 point what is that, 856. Okay, so into 100 we have to do. Coming to the third one as confidence will be this one, and boxes along with the class IDs. Can you say car, person, something? These are the class IDs. So even the cell phone also recognizing. So like that, whatever you having the availabilities, everything we have to take the requirements by using of the YOLO object detection. This is only we are applying for the requirement for the autonomous vehicles. How it will work in a real-time applications for the autonomous vehicles means, four sides we are having the cameras and we have to fix this all entire models. Then only there itself it's trying to give the output, right? So that is only the YOLO object detection part. In the same manner, SSD of object detection also will be there. So this is the process of YOLO object detection. Hope you understand this one. So please try to understand the concept, the same thing we are following. So we are taking same libraries. So that will be the content for today. Having any doubts, you can keep the message in a chat box. Otherwise, we can close the session. Thank you. If you're having any doubts, you want to say something, if you want to ask any questions, please try to share in chat box itself. Regarding for the content, what is it, data, if you need anything about from this particular, because some people are asking about the code and presentation and all, right? So please keep the message in a WhatsApp, what you are having a WhatsApp from the Pantech, then please proceed with that and it will be the useful to you. Why the name is YOLO? So actually the name came from because of the image classification purpose only. Normal CNN is okay. If you are taking the YOLO CNN, that will be different because it's dividing the picture into a small boxes. So then only the architecture will be a clear architecture. That's why you're calling it as a YOLO. You only look once. Once it's recognizing means easily it can identify the all object things. That's why only we are calling it as a YOLO. Okay, I'll show you the part. Here you can see like this it can take actually. So each and every option it can divide into the particular boxes like this. That's why we are calling it as a YOLO. So that's why you can see in real-time applications also for buses or something. So it's like advanced thing. Okay, so we can use for any of advanced things for this YOLO object detection. So these things we are using for the autonomous vehicle like this. Having any doubt, you can give the message. Otherwise, we can leave the meeting. Thank you. Thank you all. Yes, we are using the Jupyter Notebook for normal training part. Actually, why we are using Jupyter Notebook, sometimes why we are using another prompts or something means. So Jupyter Notebook or Colab will work for the training of the database. If you want to do the predictions, then you can use any type of other options. That's it. Thank you.